Okay, um, so hopefully you've worked through these practice problems. Um, let's take a look at them. Number 3, uh, the fourth root of 625 is 5, and the cube root of 0 is 0. Now notice it does say find all roots, and this is where we need to also consider if there are negative solutions. So when we did the cube root, the only solution was 3, because 3 times 3 is 9, times 3 is 27. And if I threw a negative in there, if they were all negative, we'd have a negative solution. However, now if I look over here at the fourth roots of 625, that could be 5 times 5 times 5 times 5, but it could also be negative 5 times negative 5 times negative 5. So that one would actually have 2 answers. So that's something I missed right away. Cube roots of 0 are 0. All right, let's go down to the next row. We did the first one together, number 5. Number 6 is very similar. Take that fourth root of 32, the fourth root of x to the fourth, and you get 2 over x. And 7 and 8 are ones that people seem to struggle with a little bit before, and right when we first started doing this. So let's take a look at number 7 and 8. 7, you're going to take the cube root of each thing separately. Cube root of 125 is 5. I think that's pretty self-explanatory. Let's see here, I'll try highlighting. We also have the cube root of x to the 6. Remember that shortcut. We can divide the 6 by the 3. Okay, we can take our radicand and divide it by the index. And so 6 divided by 3 is 2. So that's where that x squared comes from. Now, cube root of 6, we don't know. That's not an integer answer. So what we're going to have to do is rationalize our denominator. And so to rationalize our denominator, we need to write out the cube root of 6. We need to see it 3 times. 1, 2, 3. And the reason we need to see 3 in a row down here is because we have a cube root. If it was a square root, we need 2. If it was a fourth root, we'd want to see 4. But once I see 3 in a row, those cube roots will cancel, and I'll just have a 6 on the bottom. But don't forget, we need to also multiply our numerators. Okay? And so that's how I get the cube root of 36. I multiply together. 6 times 6 is 36. All right, last one is just a square root problem. Okay, so the square root of 50, you should be able to simplify just fine on your own. Square root of x cubed. I'm still going to break it down. I'm going to say, well, what perfect squares do I have in x cubed? Well, I have 1x squared, and then I have that x left over. The square root of x squared is x. Square root of x is as simple as it can go, and I put together my answer. Okay. All right, so let's move on to some new information here. All of these notes are in Schoology, so if I go a little too quick, or if sometimes my face is blocking it, these are all in Schoology, and I suggest that you take notes along with me. So put these notes in Notability like I've been doing, or just use your notebook again. Okay. We're going to look at rational exponents. A rational exponent is an exponent that's expressed as a fraction. Rational numbers are fractions. And so what happens is our index that we had right here, that fourth root, that is always going to be the denominator of our rational exponent. Where the numerator comes from, if you look at the second one where I have the 8 over 2/3, it comes from the exponent in the radicand. That exponent could be outside the parentheses, or it could be underneath the radical symbol. It can come from either place. Notice this note for you here, though. It doesn't matter what order you evaluate these things in, you just do whatever seems easiest. So for example, if I use the example that's given here in numbers, 8 to the 2/3 power, I can do either part first. I could do 8 squared first and get 64, and then take the cube root of 64 to get to that denominator. Or what I could do instead, because I actually don't like that one, cube root of 64, I'm not quite sure what that is. Oh, I think it's 4. I can go the other way, and I could say, well, the cube root of 8 is just 2, and then 2 squared is 4. So I can do it in either order. Whatever is easiest for me is what I should do. All of these properties of exponents that you learned about in middle school, they still hold, okay? The key is still the same, that they have to have the same base. So if I have right here in that first row, oops, I'm hitting my eraser. If I have a product of powers, what I can do if they have the same base is I can just add those exponents and then simplify afterward. If I have a quotient of problems, again, same base, I can subtract the exponents, simplify afterward. Power of powers, okay, just like before, multiply your two exponents and simplify when you're done. Power of a product. So if I have this product in the parentheses, a power on the outside, I can distribute it to each thing inside and simplify them separately. And last one, if I have a power of a quotient, I can again distribute that exponent to each thing inside, and then I can evaluate them separately and look at the fraction when I'm done. All these rules are rules that you have been using for years when it comes to exponents. All right, let's try a few together, and then I'll ask you to pause the video and try a few on your own, and we'll check our answers together. All right, first one, I see two powers with the same base. I see they're being multiplied, so I know I can add their exponents. When I add fractions, they have to have a common denominator, and I am in luck. These do have a common denominator. So I can add together my numerators. 7 plus 11 is 18, and then 18 over 9 is my exponent. Now 18 over 9 I know is 2, so this is just 7 to the second power, which is 49. All right, letter B. Oops, you can't see that. Sorry. All right, letter B. I see two powers. They have the same base, and they are a quotient, which means I can subtract the exponents. So my exponents are 3/4 and 5/4. Where is the bigger exponent? Is it on top or bottom? It is on bottom. So I know I am going to have a 1 on top, and then I'm going to have a 16 on bottom, and then I have to do 5/4 minus 3/4, which is 2/4, which is 1/2. Okay. Now I'm going to keep simplifying because remember, it's not good to have an exponent in our denominator like this, and also 1/2 power, that's the same as the square root. So this is 1 over the square root of 16, okay? Because the denominator becomes the index, the square root of 16 is 4, 1/4. Okay. Here's some extra practice for you. I'd like you to pause the video at this point, and then come back and check your answers. We're back! I hope you actually paused the video. All right, first one, we're going to add our exponents here. So I'll have 13 to the 4/2 power, which is just 13 squared, which is 169. All right, let's check the second one. That one's similar to the one we did on the previous screen. Again, same base, different exponents. We should subtract them. So I'll subtract these two fractions, 4/3 minus 2/3. So I will just have 9 and 2/3. There is a larger exponent on top, a smaller one on bottom. So I could put a 1 on the bottom, but we all know that that is not necessary. 9 to the 2/3 power, okay? So remember, this is the exponent, the 2. The 3 is the index. Do I know the cubed root of 9? I don't. So what I'm going to do is square it first. I'm going to do 9 squared. So I have 81 to the 1/3 power, which means what is the cubed root of 81? What is the cubed root of 81? I don't know. Let's try it out. I don't think it's an integer answer. in which case we would just leave our answer as is. Yeah, that's it. Cube root of 81. Next one, we have a power of powers. What we do is we multiply our exponents. So I'd have 64 to the 1/6 power. But now I have to simplify that, and I'm not quite sure how I want to simplify that. So I think before I multiply, I'm actually instead going to just evaluate 64 to the 1/2 power, which is 8, and then take 8 to the 1/3 power, which is just the cube root of 8, and know that that's 2. So notice, it's all about what's easiest for you, what jumps out to you. And you might do something like multiply 1/2 and 1/3 and get 1/6, and then realize, I don't know where to go from here. So then back it up and say, well, I do know 64 to the 1/2 power just means the square root of 64. I know that's 8, and take it from there. All right, let's look at 24. So before we do anything, I see a 1/3 power. That means a cube root. Do you know the cube root of 8? Do you know the cube root of 27? I think you do. So let's simplify that first. Cube root of 8 is just 2. Cube root of 27 is 3. Our answer is 2/3. Okay. All right, let's fill in the blanks here, summarize what we talked about. Oh, you got to be able to see the blank to fill in the blank. Properties of roots apply only to radicals with the same what? The same base, just like in middle school. Properties of rational exponents only apply to powers with the same, same answer again, base. Oh, I read the top one wrong. I'm sorry. I make mistakes in videos too. Properties of roots only apply to radicals with the same index. Okay. All right, your assignment is there. We'll chat about that sometime on Tuesday. So I would start looking at that soon, so then you've got some good questions prepared when we discuss this. All right, take care.